per hour. And that's a rate. Anything that is a variable per another variable, dollars per hour is a rate. So he's getting paid $7.50 per hour. All right, let's see what John's up to here. John is also the name of my brother, Brother John. John can carry 6 boxes in one trip. Vanessa can carry, okay, so hold on, let's take a look at this here. So John can carry 6 boxes in one trip. So he can carry 6 boxes per trip. Vanessa can carry 12 boxes for every 3 trips. So that means she can carry 4 boxes per trip. And Tom, good old Tom, can carry 16 boxes in 2 trips, which equals 8 boxes per trip. Okay, so let's graph these real quick. Our x-axis will be our independent variable, and so the number of boxes carried depends on the number of trips we take. So we'll label this one trips, this one boxes. And okay, when they've all taken 0 trips, they've all carried 0 boxes. So that's our first point for all 3 of them. And so on trip 1, John can carry 6 boxes. 1, 2, let's label these. 2, 4, 6, 8. So John can carry 6 boxes. There's John. We'll draw his little line there. Vanessa can carry 4 boxes in a trip. Okay, so there's Vanessa. And Tom can carry 8 boxes in one trip. Wow, Tom. Wow. Okay, and there's Tom's line right here. So there's Tom, there's John, and there's Vanessa. So the y-intercept of all 3 graphs is 0. Because when they've all taken 0 trips, they've carried 0 boxes. John's graph is the steepest. False. We see that Tom's is clearly the steepest. Yes, Tom's is the steepest. Vanessa's is the flattest. John's graph is between Tom and John's. Okay, that was written incorrectly. I'll change this to say Vanessa. Vanessa's graph is between Tom and John's. That's false. All right, let's move right along to number 23 and 24. Name the correlations shown by these scatter plots. Okay, remember our choices are either none, positive, or negative. Okay, here we can't really tell what willy-nilly direction our data is trending, so that's the correlation there. Here's a positive correlation. Here's a negative correlation because it's going up and it's going down. So that's positive, negative, and none. Okay, directions for 24. Sketch a graph for each statement below and determine the correlation of each graph. Label the axes. Oof, boy, label the axes. If there's nothing that makes my blood boil hotter, it's when my dear students forget to label the axes. So, I suggest we label the axes. So, Alex walks towards the house. How should we label the axes? Well, what I would suggest is he's walking towards the house over time. And so we want to measure over here. Ooh, this is going to be tricky. I can't write sideways with this thing. Wait, maybe I can. Hold on. And so this would be, wow. Okay, that is not going to work out. I just tried to turn my drawing pad sideways and it was a incredible failure on my part. So on this one we should label it distance. Distance towards. Or no, that's a poor word choice. Poor word choice. Distance from house. Distance from house. So tell me, as Alex walks towards the house, what is true about his distance from the house? Does he get further away or closer? He gets closer. So his distance from the house decreases until he eventually, well, that arrow is inaccurate, until he eventually reaches the house. Alright, same story with Megan. Distance from her house. We must protect this house. Under Armour. So when she backs away from the house, so she goes further away from the house, and then she walks towards it, then she goes back to the house. So her distance from the house initially increases, but then when she walks towards it, it decreases. Correlation here, negative. Correlation here, I just put none. There's no correlation. It's positive over here, then negative over here, but none's fine. Alright. And we'll simplify. Oh, golly, look at all of these guys. Alright, I'll take care of these in my next video.